Okay, welcome. So today in class we looked at 4 specific situations where you tackle graphing lines differently. So one of them was the intercept form, the one you're probably going to see the most, which is questions like this. 5x plus 7y equals 70. Okay? With this you decide you will find the intercepts on the x and the y axis. To do that, if you want to be on the x-axis, you want the y value to be 0, so you cover up the y value, and you get x is equal to 70 over 5. 5x equals 70. So x is equal to 70 over 5, which is 14. I'm not working to scale here. Okay, and then if you want to come onto the y-axis, cover up the x value because it'll be 0, and you get y is 10. Again, I'm not counting boxes or working to scale. Call that 10. You will do when you're doing exams, and you'll be given a grid to work into. Okay, and there's your line. Very simple. Okay, another situation you'll get is when you're given the equation of the line in terms of the slope and the intercept. For that situation, you start with the intercept down 3, then you go forward 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, even generating a second point. And forgive the bell there now, but I'm not starting again, so here we are. There's your second point, and that would be one way to generate a line. You would have your 0 minus 3, and here you'd have to work. What you've done from there is you've jumped forward 3 and up 5, so this would be 3, 2. So there's another little exercise to calculate that coordinate. And then you've got your equation of you've got your graph of your line. So that's your second graph where you start off with slope-intercept form. Another form, which is formula halfway down page 18, is the point-slope equation, where this is on x1, y1, that's the point, and the slope is m. And so what does that look like in reality? Well, you might be given an equation like y minus 3 is equal to, we'll keep this nice and handy now, 2 over 3 x plus 5. So looking at this plus 5, you will be on minus 5. Because the fact that the signs switch between the factors, the y factor here, which is the difference in y's, and the difference in x's. So you see a positive y turning into y minus y1. So when you see plus 5 here, it means that is minus 5 for the point x value, and plus 3 because of this. So you start your graph back 5, up 3, and then you would do a forward 3 and up 2, okay, which would be forward 3 and up 2, and you can work out the new coordinates. Forward 3 would get you to minus 2, and up 2 would get you to 5, so that would be minus 2, 5. You join them together and you'd have your line. Okay, so there are the 3 cases of the line, but then there are verticals and horizontals. So what do we do with this line here, where you're at 1, 2, 3, 4, 5, 6, say. Okay, so where it goes through 0, 6, but you see it goes through every possible x value. You name an x value, it can have it. So that means the x isn't even in the formula. It's only the y is in the formula. So if it's parallel with the x-axis, there's a y in the formula, y equals 6. So y equals, think horizontal. Okay, down negative, let's say you're down 7, then that'll be y equals minus 7. Similarly, if we're going to be vertical, then we only care about the x value. So if you're parallel with the y-axis, you only have an x value. And the x value is whatever this is. Or this, or this, or this, because they're all the same. So if you're out 1, 2, 3, 4, 5, 6, then it's x equals 6. If you're back here, it's going to be x equals minus something. Okay, they're all your situations, and I'm going to do your homework for you, but I'll do that in the next video. Thank you.